So hello, assalamualaikum. My name is Adi, and I'll be starting off this demo by talking about the problem statement. So Telkom Malaysia is a critical part of Malaysia's digital infrastructure, but through our threat modeling and risk assessment, we found that several of the systems are exposed to serious cybersecurity risk. So using the STRIDE framework, we identified key threats such as spoofing, tampering, information disclosure, denial of service, and privilege escalation. These threats target systems like the MITM web portal, CRM, billing systems, and cloud infrastructure. So for instance, the MITM portal lacks multi-factor authentication and strong session management, which makes it vulnerable to spoofing attacks where attackers can impersonate real users. In the CRM and billing systems, the absence of proper input validation and logging opens the door for data tampering, where malicious users can modify records without leaving a trace. We also discovered that sensitive customer data stored in the customer data warehouse lacks adequate encryption, increasing the risk of information disclosure. And in systems where access flows are weak or misconfigured, privilege escalation could give attackers full control over critical services. So, to address these issues, we implemented a layered security approach focusing on authentication, data protection, access control, and traceability. One of the most important fixes was adding multi-factor authentication to user-facing systems like the MITM portal and internal login systems. This prevents spoofing by requiring users to verify their identity using 2 or more factors. So next we implemented the AES config encryption for sensitive information such as emails and phone numbers. This ensures that even if data is intercepted or the database is compromised, the information remains unreadable without the proper key and IV. We also added an audit trail feature which records every user action, including logins, timestamps, and specific activities. This enables admins to trace what happened, when, and who was responsible. It supports non-repudiation and improves accountability across the system. On top of that, we applied role-based access control to ensure only authorized users can access high-privilege features. This prevents privilege escalation by strictly separating admin and user roles. So that's all for the demo.
I will explain about registration page process. So first, as you can see here on our web page, this is our registration form. User need to fill in their detail to get started. So this is demonstrate live. So first, user need to insert username, password, email, and phone number. So when we click register button, something happen behind the scene. So first, encrypting sensitive data. We use AES encryption with PHP function to protect the email and phone number. AES use a secret key to encrypt and decrypt the data. So we must use the same key again later when we want to decrypt it. In addition, we also use something called an IV or initialization vector. The IV help generate different encrypt result even if the input is the same. So attacker can't guess or compare value easily. Second, is password security. The password entered by the user is hashed using PHP function. This means the actual password is never stored in the database. Instead, we store in a long scrambled code. This helps protect user account even if the database is leaked. Lastly, SQL injection protection. When saving this user into the database, we also use parameterized query or prepare statement. This is important to prevent SQL injection, where someone might try to break into or manipulate our database. With prepare statement, the SQL command and user input are separate. So even if someone try to inject code through a file, it won't work. They can't just edit or change our SQL command like that. So the outcome of the registration, we can see that in the database using PHP MyAdmin, you can see a new user has been added. The username appears clearly, the password is hashed, and the email and phone number file are encrypted. So this help us protect user privacy and ensure secure access to the system. That's all from me.
Okay, next I will explain about the login. So the login is basically only for the admin. So here's the example of the non-admin, which is like back then Sophie tried to register. So we use her example. So Sophie, and the password is Sophie. So here is the example that says only admin is allowed to log in. So we will try about the real admin. So we try about the Nina. So from here, we can say that Nina is the real admin. So she can look all the audit logs activity, which is how the user registered or the login failed or anything happened in the activity of audit. So here is the backend, which is the login demo. So So from here, we can say that it is connected to the database. And also, additionally, we use the method of post. The method of post basically just more secure, like the user data is not exposed to the URL. So next, we also use the same parameter and the SQL injection prevention in our selected in user ID, password, and everything. And then we verify the password. So from the verification of password, we can say that only the admin allowed to enter to the login page. So here is the location, which is to this coding, and it will echo wrong password and user not found if she was not the real admin. So then we will see about the audit backend. This is the audit, which is the same, which is we'll identify about the role of the admin. So we identify the and link from the login demo PHP. So that's all from me.
Hi, I'm Yasmin, and I will explain about the database. So first of all, I will show you about the tables. So as you can see, we have several tables for this demonstration that have been built in PHP MyAdmin as a medium to handle the database. So it started with the AIS project, which is it stored all the data in the table. So we have some table. First we have users, audit logs, and login logs. So next we have the table user. So this table user is shown that all the users that have been registered in the system, the information will be saved after the registration process. So the important data such as password already have been hashed, user email and user phone have been decrypted. So the table also include IV data for each registration attempt. Moreover, for the user role, it was created to categorize between the general user and the authorized admin. So can we go to the coding to show that only admin, only the role that have been assigned to the database, which is the only admin can only view the database. Other than admin, they cannot access the database. So next, admin can also change the user role. So can you back to the table? So you can see that the user role at the end of the database can be chosen by admin to show that they admin or not. The user can change whether the user that registered is an admin or not. So next, table login. So the table login displays user login activities, which include when and who log into the system. Each row include login ID, user ID, the date of the time of the login, whether it was successful, and the IP address used. So as you can see, the IP address here shows 1, which is the system have been logged by the local network. They will show 1, and the success shows 1, which is the user successfully logged into the system. Next, we have the table audit. So the audit table shows a record of the system activities such as user registration and successful login. Each entry will include a unique ID, the type of action like user registered or user successfully logged in. You can see that. So the LID that shows null, it means that the user only registered to the system. They didn't enter the system just yet. So the status will be null. Means that without a login reference. This help track who did what and when. It also shows the timestamp so the admin can see what the user did in what time and what date. So thus it is making the system more secure and transparent. That's all from me. Thank you.
Let me walk you through how this decrypt demo.php script works step by step. This script connects to a database which fetches encrypted user data, decrypts it, and displays it in a readable format. So step 1 is the database connection. This part connects to the MySQL database named AIS project. We are using localhost with the root user and no password for now. If the connection fails, it stops and shows an error. Step 2 is the AES encryption configuration. Here we set the key and cipher method used for decryption. This method must match exactly with what was used during encryption. Think of the key like a password and the cipher as the encryption method. If either is different, decryption will fail. Step 3 is fetch encrypted data. This SQL query retrieves user records from the users table, including the encrypted email, phone number, and the IV and initialization vector, which is needed for decryption. Step 4 is set up the table. The script then starts to build a table in HTML to display the encrypted data. Step 5 is decrypt data in a loop. Now we look through each row. First, we decode the IV because it was stored in base64 format. Then, we use OpenSSL decrypt function to decrypt the email and phone using the cipher, key, and IV. If everything matches, we get the original value. Step 6 is show the decrypted info. Each decrypted value is then displayed in the table. The ID and username are already stored in plain text, while email and phone are now shown in decrypted form. And lastly, close the connection. Finally, the database connection is closed to free up resources. So in summary, this script is very useful for testing if our encryption and decryption processes are working correctly. If we see readable emails and phone numbers in the table, we know that our decryption is successful.